Hello everyone. We'll continue the chapter classification of elements, and the topic for today is electron gain enthalpy. So first of all, we'll see what is electron gain enthalpy. So it is the change in enthalpy which takes place when a gaseous atom gains an extra electron to form monovalent gaseous anion. So it is noted by delta EGH. So the energy is released in attraction when atom gains an electron. So the value of delta EGH is negative in such cases. Greater the A's with which the electron is added, more negative is the electron gain enthalpy. So first thing is, it is the energy, it is the enthalpy change, energy change, which takes place when a gaseous atom gains an electron. The second is, more easily it gains, more amount of energy it will release an atom. So more easily an electron is added to an atom, so it more amount of energy it will release, so more negative value of delta EGH will be there. So here is an example of oxygen gaseous atom to O negative gaseous atom. It releases 141 kilojoule per mole, and it is always given in per mole quantity, and the energy units, kilojoule or joule, are its units. So next we have other factors, other things. So the atoms which have already symmetrical electronic configurations, whether it is fully filled or half filled, symmetrical electronic configuration, such cases atoms don't have any urge to gain extra electron. So in those cases, we have to provide energy to add an extra electron to the atom. So noble gases, alkaline earth metals, beryllium, magnesium are such cases. Now the second case is when we have to add an electron in an anion, O negative, for example. So extra electron is to be added to form O2 negative. We have to provide energy because there is repulsion. There are repulsions between the negative charge on the anion and the incoming electron. So we have to provide energy in such cases. So in such cases, the electron gain enthalpy again is positive. Now, next we have factors on which it depends. The first factor is atomic size. So the electron can be added to the atom if it is more easily if it is smaller. Atom is smaller. So it is accepted that down the group, when the size of atom increases, the value of electron gain enthalpy becomes less negative. So the atoms become have less urge to gain electron. So nuclear charge is the factor related to atomic size again. So smaller the size, more negative enthalpy, more electron gain enthalpy, negative electron gain enthalpy, more release of energy, easy to take up the electron by the atom. So it all depends on nuclear charge. So more the nuclear charge, more negative is the electron gain enthalpy. The third factor is symmetrical electronic configurations. So half filled and fully filled electronic configurations don't have any urge to take extra electrons. Now, general trend, expectations for general trends. So while moving from left to right in the period, the atomic size decreases. Hence, the nuclear charge, effective nuclear charge, increases, and the electron gain enthalpy becomes more and more negative because the addition of an extra electron in such cases is more easy. Now, while going down the group, the size increases, nuclear charge increases, but the size overcome the charge, and ultimately the nuclear charge is less as compared to the increase in size, and the electron gain enthalpy becomes more and more positive down the group. It becomes less and less negative down the group. So it becomes more and more negative while we are moving towards right from the left, that is across the period, it becomes more and more negative, and down the group it becomes less and less negative. So next we have some specific cases, typical cases of electron gain enthalpy. So the first we have for halogens. So halogens in a particular period have most negative electron gain enthalpy value, and the reason is the electronic configuration and the size. So in any period, the halogens have the smallest atomic size. Number second, they have 2s and ns2 np5 configuration, general configuration. So they require only one electron to complete their octet. So they have very high tendency to gain an extra electron. So this is the general trend. So it becomes more and more less negative while moving down the group. So in halogens. So inside the halogens, down the group, it becomes more and more negative. And in any period, any period, so the halogens have most negative electron gain enthalpy. So here is an exception in case of fluorine and chlorine electron gain enthalpy. According to the trend, fluorine should have maximum negative gain enthalpy, but actually chlorine have. Now the explanation for this is due to the extraordinary small size of the fluorine atom, which is 72 picometer, and it has 9 electron in such a small size. So due to which the overcrowded electrons, there is electron-electron repulsions inside the atom is quite high, and it also gives repulsions to the incoming electron. So its electron gain enthalpy is not that much negative what is expected for it. So ultimately the fluorine's electron gain enthalpy becomes more negative than the fluorine. The reason behind it is the extraordinary small size of the fluorine atom, which results into electron-electron repulsions in between the atoms of the fluorine, in between the electrons of the fluorine, uh, and ultimately it also gives the repulsions to the incoming electron. So the value of electron gain enthalpy for fluorine is less negative than the expected value, and ultimately the fluorine have maximum electron gain enthalpy in halogens. The same trend is followed in case of oxygen in group number 16, where the sulfur has more negative electron gain enthalpy than the oxygen. So next we have noble gases. So in case of noble gases, the electronic configuration is symmetrical and is fully filled, and these gases do not have any urge to take up extra electron. So in these cases, the electron gain enthalpy is positive and not negative. In helium has exceptionally small electron gain enthalpy, that is 48 kilojoule, and it is due to its small size. So it has very small positive value in all the noble gases. So for helium, and this is due to its small size. So we have to give less energy in that case, but still it is positive. Beside this, the alkaline earth metals like beryllium, magnesium have positive electron gain enthalpy because the orbitals are filled. So S2, S2 in both cases, outer. In case of nitrogen, have half-filled electronic configuration, 2p3. So again, positive value of electron gain enthalpy. Now, next is the importance of electron gain enthalpy. So the two important significance, the two importance or the significance of electron gain enthalpy is it gives the electronegative nature. So the atoms which have urge to take up an electron and release energy, and their release energy are electronegative in nature. And the second is those are taking up electrons easily with the release of high energy. that is more negative electron gain enthalpy, they are good oxidizing agents because they have tendency to gain electron. So we can conclude that the oxidizing character is assessed in terms of electron gain enthalpy, electron accepting tendency, you can say that. So this is all about for the electron gain enthalpy, its definition, its trends expected, and the abnormalities in the trends also. So thanks for now.